Okay, in this video, we're going to take a look at our common right triangles. You remember the special right triangles, actually. We got our 30-degree angle, our 60-degree angle, and our 45. Now, you would think there's not much sense in drawing these two separate, but it is important that we are dealing with reference angles, not, other angles up here. Even though these are the same right triangle, it does matter which angle you're referencing here. So these are the common ones we're very familiar with, and the idea behind this is we're going to need to know the exact value of the sine, cosine, and tangent, and occasionally the other three, the cosecant, secant, and cotangent of these specific angles, a 30, a 60, a 45, as well as several quadrantal angles. Specifically, I guess you could say 0 and 90. From those, we can figure out other angles like 150 or 135, ones that have references of these types of angles. So if we can get these down, these memorized, we'll go a long way towards handling the other ones that we will run into. So one way to memorize these or start to learn to memorize these is with a simple chart. So what we'll say is, okay, we have sine, we'll pick theta, whatever, cosine theta underneath it, tangent theta. Right, and then we'll put the angles that we're going to care about here, at least to start off with. We'll say 0, and the next largest 30, 45, 60, and quadrantal at 90. And it'd be wise to know these in terms of radians. Of course, 0 is easy, that's 0 radians. 30, if you remember, is pi 6, 45 is pi fourths, 60 is pi thirds, and 90 is pi halves. It would be very wise to start to remember those as well, if we haven't already. Okay, so how this works, I think of sine, think of the graph of sine. When you graph sine, sine starts at the origin. So at 0 radians, the sine of 0 will be 0. And if you go to the next value that you would actually graph for sine, sine of pi halves would put us up at 1. And if we do cosine, just the opposite. Cosine of 0 would be 1, and cosine of pi halves, or 90, would put us at 0. Right? Then from there, we could do tangent, or we could think of the tangent graph, whichever. I was thinking in terms of sine divided by cosine is tangent. So sine divided by cosine, we'd say the tangent of 0 is 0. If you remember, tangent does go through the origin. Over here, for tangent of 90, well, sine of 90 divided by the cosine of 90, that's kind of a problem. It's undefined. Right? 1 divided by 0, we can't do that. So tangent did have a problem at pi halves. If you remember, that was a vertical asymptote for tangent, if you recall the tangent graph. Now, for these other values, we can just kind of go through our pictures over here and say, okay, what is the sine of 30, or what is the sine of pi 6? Well, sine has always been defined as opposite over hypotenuse. So sine would be 1/2. What about the cosine of 30? Well, the cosine of 30, whoops, wrong picture, would be adjacent over hypotenuse. That would be the square root of 3 over 2. And then from there, we can figure out tangent by dividing those two. Do a little math, and you would actually end up with the square root of 3 over 3. Just take sine divided by cosine. Right, 45 should be memorable. 45, opposite over hypotenuse, 1 over the square root of 2. Should be square root of 2 over 2. Cosine is exactly the same, different reason though. Adjacent over hypotenuse, square root of 2 over 2. And anytime you divide a number by itself, it will always be 1. And that shouldn't surprise us. Pi fourths was one of the values we actually graphed on the tangent function. Tangent of pi fourths is 1. All right, pi thirds, well, go with the 60 degrees. That's why I drew the separate picture. Sine is opposite over hypotenuse. So that'll be the square root of 3 over 2, not coincidentally the same thing as the cosine of 30. The whole idea behind cofunctions. The sine of 60 will equal the cosine of 30, cofunctions. Right? Likewise, the cosine of 60, or pi thirds, will be 1/2, adjacent hypotenuse. And then finally, the tangent will be the quotient of these two. You'll divide this square root of 3 over 2 divided by 1/2, which will just give you the square root of 3. Right? So this is one way to memorize. Might be easier to visualize this if these are separated. So we will do so. And these are ones we absolutely positively have to know. And the others that come along for the ride, like 120 degrees, like 315, like 270, all these other angles that are related to these, that are quadrantals or references of the 30, 45, or 60, we can figure out, and we'll get better and better at it, but we've got to at least get these memorized. And you can see there's a lot of repeats in this, and we can use the idea behind sine and cosine being cofunctions. The cosine of 60 is the same thing as the sine of 30, that sort of idea, and we can always calculate tangent from those two ratios. Right? So that is actually one way to do this. Right? A second way is one I learned at a mathematical convention. I'd never seen this method before for memorizing these values, but it seems to be pretty good. A pretty good method for doing this. And I think the guy called it the right-hand rule. The right-hand rule implying that you're using your right hand. Now, what you have to do is you have to be looking at your right hand. So, using your right hand, looking at it, you would see something like this beautiful artist rendition. That would be your right hand if you're looking at it, the palm of your hand. That's how you have to be visualizing this. All right, here's your thumb, first finger, there's your pinky. Now, as far as the angles go, each finger, including the thumb, represent a degree measure, or a radians for that matter. This right here, we're going to call pi halves. We know that to be 90 degrees. This finger here, well, that would be our next largest angle at 60 degrees, or we would say pi thirds. Again, the sooner we start associating these radians with the degrees, I think the better off we're going to be. This will be our 45, or pi fourths finger, and this finger right here will be our 30, or pi 6. Now, like I said, the thumb even plays a role. The thumb will be our 0 degree angle, or obviously 0 radians. 0 degrees or 0 radians. So it's not exactly forming that exact angle that we're talking about here, but what they do is they do go in the order in which you would see them, all right? So from largest to smallest, right? That's how we measure this. Now, they say to put a 2, the number 2, right in the palm of your hand. And that comes into play when we actually calculate this. Now, the whole idea behind the right-hand rule is you're counting the number of fingers that remain after you put one of the fingers down. So, for example, you want to find the cosine of 30 degrees. Well, that's the finger that you would actually have to put down. And you're going to count the number of fingers remaining. Now, the question is, do we count this way or do we count that way? Well, for cosine, we're always counting to the left. So as we're looking at our hand, we're going to the left and counting the number of fingers. If you're talking about sine, you count the number of fingers to the right. So here's the idea. Here's actually the formula. It's going to be the square root. I'll say that's the number of fingers remaining. Fingers remaining. And you always divide it by that number 2 in your hand. Number of fingers remaining divided by 2, that's the formula that you're going to use. Now the question is whether you're doing cosine or sine, it matters. So with cosine is always the number of fingers to the left. Sine is always the number of fingers to the right. Can remember that. This is a real easy trick for remembering all your ratios. LE sine and cosine. Tangent can be figured again with just sine over cosine. So here's an example. Say you want to know what the cosine of 30 degrees is, the exact value. And you forgot your right triangles. You forgot the radical 3, and you're not sure if it's radical 2 or if it's supposed to be 2, or you completely forgot this. Well, you go to your 30-degree angle, or pi 6, whichever. And then you count the number of fingers. Cosine goes to the left. We have 1, 2, 3 fingers remaining. 3 fingers to the left. We're going to take the square root of 3, and we're going to divide it by 2, and that's the exact value of the cosine of 30. Number of fingers, taking the square root of that, always dividing by 2. And likewise, you can find sine the same way. The sine of 30, well, this time we count the number of fingers to the right. The thumb counts, so there is 1 finger to the right. You take the square root of 1, again, divided by 2. It's always divided by 2. And the square root of 1 is just 1. And the sine of 30 is, in fact, 1/2. Now, as far as tangent is concerned, you can, of course, take sine of 30 divided by the cosine of 30. It's kind of reversed. But you would take 1/2 divided by the square root of 3 over 2. Take a little bit of work, but you would get square root of 3 over 3, which is the tangent of 30. But if you can get sine and cosine, you should be able to get tangent. Now, this particular picture here, this is the hand, an enlarged version of it. The idea is, it just helps in illustrating this point. And we can do any angle, even the quadrantals. So for example, let's say you wanted to figure out this quadrantal, you totally forgot what the sine of pi halves is or the cosine of pi halves. Well, we just put this finger down, and then we count, if we're doing cosine, the number of fingers to the left. Well, clearly there are 0 fingers to the left. So the cosine of 90 would be the square root of 0 divided by 2, or just 0. Whereas the sine of 90 would be 4 fingers to the right. Square root of 4 is 2. 2 divided by 2 is 1. And that is what the sine of 90 is, or the sine of pi halves. It will be 1. So it's not something you have to know how to do, but it is something that is very useful and a good trick to figure out these numbers if you ever forget, the chart or your right triangles. But one way or the other, these have to be memorized, right?